Welcome to The Explainer. Today, we're diving headfirst into something that sounds like it's straight out of science fiction, but I promise you, it's very real. We're talking about quantum computing, a technology that's poised to change, well, pretty much everything.
So here's what we're going to cover. First, we'll get into what exactly makes this a whole new way of computing. Then, we'll look at the global race to build these things. We'll also talk about the huge economic promise, the pretty terrifying risks that come with it, and finally, what our quantum future could hold.
Okay, to really get a feel for just how mind-bendingly powerful this is, let me ask you a question. What if a computer, instead of trying one answer at a time, could test every single possibility, all at once?
And that right there, that's the heart of quantum computing. This isn't just about making a faster laptop. No, this is a totally different beast. The idea actually goes back to the physicist Richard Feynman in the 80s. Think of it like a parallel universes calculator. It's not just doing one calculation, it's doing millions, all at the same time. This lets it solve massive problems in seconds that would take our best supercomputers thousands of years. It's a total game changer.
All right, Section 1, a new computing paradigm. Let's dig into the fundamentals here and see what makes these machines tick, and why they're so different from, say, the phone in your hand. So it all boils down to the most basic building block. The computer you're using right now uses bits. You can think of them like a light switch. It's either on, a 1, or off, a 0. Simple, right? But a quantum computer uses something called a qubit. Now, this is where it gets weird and wonderful. A qubit is more like a spinning coin. While it's in the air, it's not heads or tails. It's kind of both at the same time. That state is called superposition, and that's the secret sauce. That's what unlocks all this incredible computing power.
And look, this stuff didn't just appear out of nowhere. It's been a long time coming. It all started as an idea back in 1982 with Richard Feynman. Then, in '94, a huge breakthrough. Shor's algorithm proved a quantum computer could, in theory, break modern encryption. Fast forward to 2019, and Google claims quantum supremacy. They said their machine solved a problem in 200 seconds that would have taken the world's best supercomputer 10,000 years. We're talking about decades of work, slowly but surely making this a reality.
Okay, so now that we know what this is, who's actually building it? Well, that brings us to the global quantum race, and believe me, it is a race. So, let's be real for a second. We're in what's called the NISQ era. That stands for Noisy Intermediate Scale Quantum. What does that mean? It means today's quantum computers are kind of like the first airplanes. They're bumpy, they're experimental, they're not super reliable, but they prove that flight is possible. We're not at the 747 stage yet, but we've proven we can get off the ground.
Now, when you look at the big players, the US and China, you see something really interesting. They're playing different games. The United States is laser-focused on building the actual quantum computers, the hardware. China, on the other hand, is pouring resources into quantum communication. They launched the world's first quantum satellite way back in 2016. It's a fascinating split in strategy.
And we are talking about serious money here. The global public investment has hit $42 billion. And get this, China's public investment alone is over $15 billion of that. That tells you everything you need to know about how important this is on the world stage.
But don't get me wrong, it's not just the US-China story. Not at all. You've got giants like IBM with its 1,121 qubit chip. You've got Google pushing the envelope. Over in Europe, companies like Pascal are raising huge amounts of money, and Japan is in the game with its own advanced systems. It's a truly global effort. All right, which brings us to the big question. Why? Why all this money and effort? What is the trillion-dollar promise here?
Okay, check out this number. We're talking about a potential value of somewhere between $450 and $850 billion. And that's just by 2040. This isn't just a new gadget, it's something that could fundamentally reshape entire industries.
But, it's not just about the money. The human impact could be absolutely massive. Just think about medicine. What if you could cut the time it takes to develop a new drug from 10 years down to just a few months? That would save countless lives and, yes, billions of dollars. That's the kind of power we're talking about. And, of course, as the technology gets better, the market for it is just going to explode. Projections show it could be a nearly $200 billion market by 2040. That is a huge new sector of the economy being born right before our eyes.
And with a new industry comes new jobs. A lot of new jobs. We're looking at maybe 250,000 new quantum-related positions by 2030. That's a huge demand for a whole new set of skills.
Okay, So we've talked about the incredible promise. But there's another side to this coin, a much darker side. Let's talk about the encryption doomsday clock.
There's this term you need to know, Q-day. What is it? It's the hypothetical day a quantum computer becomes powerful enough to break the encryption that protects, well, everything. Your bank account, government secrets, your private messages, all of it, suddenly vulnerable.
And the amount of money at risk is just mind-boggling. $20 trillion. That's the estimated value of the global digital economy that Q-day puts in jeopardy. It's that serious.
But here's the truly scary part. This isn't some far-off future threat. It's happening right now. Adversaries are stealing huge amounts of encrypted data today and just storing it. They're playing the long game, waiting for a quantum computer powerful enough to crack it all open. They call it harvest now, decrypt later.
So, you've got this incredible promise and this huge looming threat. Where do we go from here? What does our quantum future actually look like?
Well, experts kind of see a few different ways this could play out. The first is called advantage waves. The idea here is that by 2030, we'll see quantum computers giving us a major edge in specific industries, like developing new chemicals or in finance. Then there's the full-scale scenario, where we see widespread adoption transforming the whole economy by 2040 or 2050. But there's also a delayed path, where progress stalls because the technical challenges, like errors and scaling up, just prove too hard to solve for now.
The bottom line is this. Quantum computing isn't a what-if anymore. It's a when. It's being built as we speak in labs all across the globe. And that really leaves us with a huge question, and not just for the scientists, but for every single one of us. The quantum future is coming. The real question is, are we ready for it?